So in today's video, we are going to focus on sinusoidal current and sinusoidal voltage. Now, a sinusoid is basically a signal that has the form of the sine or the cosine function, and it is the sinusoidal voltage that produces the sinusoidal current, unless of course the circuit is non-linear. Now, the sinusoidal voltage can be expressed as V of t equals Vm sine omega t, where we have Vm to be the amplitude of the sinusoid. So we have Vm, that is amplitude of the sinusoid, and that is in volts. We have omega, that is called the angular frequency, and that is also in radians per second. And then we also have omega t, that is called the argument of the sinusoid, or basically the angle. So that is argument of the sinusoid. Now, we can as well express the sinusoidal voltage, that is V of t, as Vm sine 2 pi ft. Now let's call this equation 1 and let's call this equation 2. So comparing the two equations, we can say that omega is equal to 2 pi f, where we have f to be the frequency of the sinusoid, or better still, the frequency of the signal, and we have that in hertz. Now we have frequency to be the reciprocal of the period of the signal, so that is 1 over t, where t is called the period of the signal. In that case, we can have omega equals 2 pi times 1 over t, and that is equal to 2 pi over t. So now let's look at an example of a sinusoid that is represented as a function of its argument. So we have this to be V of t, and then we have this to be omega t. That is because the signal is represented as a function of its argument. So this is the sinusoid. And then we have this to be the peak value, or the amplitude, that is Vm. And then we have this also to be negative Vm. Now we call this the positive half cycle, and this is called the negative half cycle. So we have this to be 0, this to be pi, and then 2 pi, 3 pi, and then 4 pi. So as we said earlier on, Vm is called the peak value, or the amplitude. Now looking at this graph, you realize that the signal repeats after every 2 pi. So from 0 to 2 pi is one complete cycle. From 2 pi through to 4 pi is also another complete cycle. So we have from 0 through to 2 pi to be one complete cycle. And the duration of a complete cycle is what we call the period of the signal. So the period of this sinusoid is equal to 2 pi. So now let's consider a more general expression for the sinusoidal voltage, that is V of t equals Vm sine omega t plus phi, where we have omega t plus phi to be the argument, and then we have phi to be the phase or the phase angle. Now the two can either be in degrees or in radians. Also, let's consider two sinusoidal voltages, V1 of t to be Vm sine omega t, and then we have V2 of t also to be Vm sine omega t plus phi. So what do you think actually happens here? Now what happens here is that since V2 has a phase of phi, it means that V2 occurs first in time. Therefore, V2 is said to lead V1 by phi. So we have V2 leads V1 by phi. Now we can as well say that V1 lags V2 by phi. So any of the two is correct. Either V2 leads V1 by phi or V1 lags V2 by phi. Now if phi is not equal to 0, then what this primarily means is that V1 and V2 are out of phase. So V1 and V2 are out of phase. That is where phi is not equal to 0. However, if phi is equal to 0, then it means that V1 and V2 are both in phase. So V1 and V2 are in phase, and they reach their minima and maxima at exactly the same time. Now let's make this more practical. Let's assume that we have a sinusoidal voltage, that is V of t, which is equal to Vm sine omega t. And this sinusoidal voltage produces a sinusoidal current, I of t, which is giving us Im sine omega t plus 30 degrees. Now we can represent this in the phasor diagram as we are going to consider V of t to be the reference phasor. So we have V, and then since the current has a phase angle of 30 degrees, this is going to be the current, and the current is leading the voltage by 30 degrees. So the phase angle between the current and the voltage is 30 degrees. So we can say that I leads V by 30 degrees, or better still, V lags I by 30 degrees. Now V lags I by 30 degrees simply because if we want V to point in the direction of I, then we need to rotate V in the anticlockwise way, that is 30 degrees, in order to point in the direction of I. Now let's consider some examples. So considering our first example, given the sinusoidal voltage V of t equals 50 cos into bracket 30t plus 10 degrees V, find A, the amplitude Vm, B, the period t, C, the frequency f, and then D, V of t at t equals 10 milliseconds. So how do we solve for A, B, C, and D? Now we said that a sinusoid can be represented as a sine or a cosine function. Now from this question, we have the sinusoidal voltage represented as a cosine function. Now the best thing we need to do is to compare this equation with the general form of a sinusoidal wave, considering the cosine function. So let's consider the sinusoidal voltage V of t in the question to be equation 1. So we have v of t equals 50 cos into bracket 30t plus 10 degrees. Let's call this equation 1. And then the general form of a sinusoidal waveform, that is considering the cosine function. So we have Vm cos omega t plus phi. Now let's call this equation 2. Don't forget that we have Vm to be the amplitude, omega t to be the argument, and then omega the angular frequency, and phi to be the phase angle. Now let's find the value of the amplitude, that is A. So comparing these two equations, it is obvious that the amplitude of this signal is equal to 50 volts. So straight away, we have Vm equals 50 volts. Now to B. So for B, we are asked to find the period of the signal. Now we know that the angular frequency omega is equal to 2 pi over t, where t is the period of the signal. Now considering these two equations, you realize that omega is equal to 30. Therefore, we have 2 pi over t equals 30. Now let's try to find the value of t. So we interchange the positions of t and then 30, so that we have t equals 2 pi over 30, and that is equal to 0.2094 seconds. Now let's leave our answer in milliseconds. So to do so, we are basically going to move 3 decimal places to the right. So we have 1, 2, 3. Therefore, the period t is equal to 209.4 milliseconds. Now to C, we are asked to find the frequency of the signal. Now we know that frequency is given by the reciprocal of the period of the signal. So we have f equals 1 over t, which is 0.2094. We are using the value in seconds. So therefore we have f to be equal to 4.7755, and that is equal to 4.78 Hz. Now to D, we are asked to find the value of V of t at t equals 10 milliseconds. So what we need to do at first is to convert t from milliseconds to seconds. Now milliseconds means that we are going to multiply by 10 to the power negative 3. Therefore, if we have 10 milliseconds, then that is basically t equals 10 times 10 to the power negative 3, and that is equal to 0.01 seconds. So this is the equivalent value in seconds. So using the equation, that is V of t equals 50 cos 30t plus 10 degrees, we are basically going to substitute the value of t into this equation. Therefore, we have V of t equals 50 cos 30 times t, that is 0.01 plus 10 degrees. So this becomes 50 cos, now 30 times 0.01 is equal to 0.3 plus 10 degrees. Notice that this value is in radians. Therefore, we can't add 0.3 to 10 degrees. So we need to convert this value from radians to degrees. Now pi is equal to 180 degrees. Therefore, 0.3 is equal to what value? So we have x equals 0.3 times 180 degrees divided by pi, and then that gives 17.189 degrees. So this is the value, or the equivalent value, in degrees. So let's insert that in here. So therefore we have 50 cos 17.189, that is in degrees, plus 10 degrees. Therefore this becomes 50 cos 27.189 degrees, and that gives 44.48 volts. So this is the value of V of t at t equals 10 milliseconds. Now let's take the second example. So for example 2, find the amplitude, frequency, and the RMS values of the following quantities. We have A, V of t equals 5 root 2 sine into brackets 100t plus 30 degrees. And then we have B, that is I of t equals 30 sine into brackets 2t plus 90 degrees. So how do we find the amplitude, frequency, and the RMS values of these quantities? Now, because we have these quantities in the form of a sine wave, then we are going to compare V of t and I of t to the general form of a sinusoid considering the sine function. So for A, we are going to compare this equation to V of t equals Vm sine omega t plus phi. Now let's call this equation 1. Let's call this equation 2. Now to find the amplitude, we know that the amplitude is Vm, and comparing the two equations, you realize that the amplitude is 5 root 2. So we have 5 root 2 volts. So that is the amplitude. Now let's find the frequency. So for the frequency, we know that omega is equal to 2 pi f. And considering the two equations, we have 100 equals omega. Therefore, we equate this to 100. And then we want to divide through by 2 pi. Therefore, f is equal to 2 goes here once, 2 goes here 50 times. Therefore, we have f equals 50 divided by pi, and that is equal to 15.92 Hz. So this is the value of the frequency. Now to the RMS value. So the RMS value of a sinusoidal function is given by the RMS value is equal to the amplitude divided by root 2. Therefore, we have Vm to be 5 root 2. We insert that here so that we have 5 root 2 divided by root 2. So that we have Vrms to be equal to 5 volts. So these are the values of Vm, F, and then Vrms. Now let's solve for B. So for B, let's compare this equation. Let's call this equation 3 to I of t equals Im sine omega t plus phi. Now we are going to find the amplitude, the frequency, and the RMS value. So we have Im, which is the amplitude, to be equal to 30 that is comparing the two equations. So that is 30 amperes. Now to the frequency. So to find the frequency, we know that omega is equal to 2 pi f, and that is equal to 2. So to find the value of f, we simply divide by 2 pi, and then we have f equals 1 over pi, which is equal to 0.3183 Hz. Now for the RMS value, we have IRMS equals Im divided by √2. We have Im to be 30, therefore 30 divided by √2, and that's equal to 21.21 amperes. Therefore we have IRMS to be equal to 21.21 amperes. So that's it for today's video. Thanks for watching, and see you in my next video. Bye bye.